Okay, so in this question, we're looking at the forces that are applied to a wooden crate moving on a horizontal plane. So let's just get our diagram and try and add all of the forces that we can to it. So the mass is 20 kilograms, meaning that the weight is going to be 20 G. We've got this diagonal force of 40 newtons. We'll try and find out what the horizontal and vertical components are. The angle is alpha. We've been told, well, let's get the reaction force on first. We've been told that the friction, or the coefficient of friction, is 0.14. So that's 0.14 multiplied by the reaction force. And then we have these horizontal and vertical components. We've been told that tan alpha is 3/4. So using our standard triangle, we can get expressions for cosine alpha and also for sine alpha. And that's going to be 3/5 for cosine alpha and 4/5 for sine alpha. Okay, and now we can start to resolve. So let's start by resolving vertically. So the reaction force plus the vertical component of the tension should equal 20 G, vertical component being 40 sine alpha. Sine alpha we already found was 4/5. So 40 sine alpha equals 20 G. On the next line, I'll make it a little bit more. On the next line, I'll substitute. So R plus 40 times 4/5 equals 20 G. And we can just rearrange this to get R as the subject. I don't really need to get an exact answer for R. I actually prefer to leave it as this expression and use that going forwards. Okay, so let's also resolve horizontally. Okay, so resolving horizontally, we can go ahead and make use of Newton's second law, F equals ma. So I'm just going to get all of the forces. So the positive direction force is going to be the horizontal component of the tension, so 40 cosine alpha, and the negative or the opposite direction, the opposing direction, is going to be the friction, 0.14 R. And together that should equal mass times acceleration. Substituting in the values or the expressions that we know, we're trying to find acceleration. So I can divide by 20, and really all at once, I'm going to put this into the calculator. It's going to give me quite an exact answer. I haven't done any rounding up to now. And that gives me an answer of 0.396 meters per second squared. And that's obviously to 3 significant figures. In part B, we've been asked to explain what would be the difference if we were pushing with the handle instead of pulling. Things are still the same, as in the force is still 40 newtons and the angle is still alpha, but what would happen to the acceleration? Well, with this push, the reaction force is going to increase because the vertical component of the force that we're using is going down rather than up, which means the reaction force has to be larger to balance it out. If the reaction force is larger, that means that the friction will also be larger, since friction is a scaled version of the reaction force, which then means the acceleration would be less because there's more work that needs to be done. There's a greater force that needs to be used to move this object in the positive direction. So to sum it up in a couple of sentences, the reaction force increases as the vertical component of the driving force is down rather than up. This in turn increases the friction. Increased friction will work to reduce acceleration.